Hi, welcome back to PRT. In this episode, I thought that we should take a look at a peripheral called RTC. And that is a peripheral that is available in all STM32s and a very common one to tell time and date and alarms. So I thought that we should take a peek on this one and how to use it, and also to make some how we can set the date, time, and alarms, and via using a UART, and then also having a small OLED to present this date and information on. So if this sounds interesting, please tag along. Okay, so here we have started STM32 Cube IDE, and I'm running the currently latest version, and that is the version 1.16.0. If you run an old version of the STM32 Cube IDE, I recommend to update it to the latest version. So to start a new project, we do like we always do. We start with File, New, and STM32 project. And then it will be launching the STM32 CubeMX. So I got a question in my chat saying that I'm running STM32 Cube IDE, but I don't have CubeMX. And if you did an installation from ST's website, you should have also the CubeMX, but you're maybe not aware of that this is the part of STM32 CubeMX. And CubeMX you can actually install as a separate program, standalone, if you prefer another IDE like Visual Code Studio, or if you like Kyle or IAR. Then you can use the CubeMX to configure a microcontroller. So in this case, in this application, I went for the Nucleo G071 board, but it's a universal. You can run with any microcontroller board that you have. And we go with next, and we give it a name. Like that. Okay, so we just hit finish. So you're not forced to use CubeMX. You can do whatever you want without using CubeMX by writing your own code. But CubeMX is a way to make everything uniform, make it easy to transport and migrate to others, microcontrollers. And it makes it visual. So we can go with looking into sys and see that we have here wire debugger enabled, which we do by default. So then we go to take on clock. And since we are going to use an RTC, I would like to have crystals. So we go with the crystal ceramic resonator here. And here we can just disable the high speed and just work with the internal clock instead. We then go to timers and we enable the RTC. And we activate the clock source there. Then we have a selection also if we only want to have the RTC or if we also would like to have the calendar. And in my example, we are using the calendar and we are using one alarm. So we use the alarm A. And we can then choose if we would like to have an interrupt for when there is an alarm, or if we should route that directly to an output pin. I selected as an internal alarm. And for that, I'm getting an interrupt, and I need to enable that one. We do it like that. You could then also set all the timers and all the dates, and so it's already starting with 2024, for instance, instead of 2000 year. But I don't bother with this. I will just leave it as it is. We can then go back to the clock configuration whilst we have enabled the RTC. That makes us possible to change this multiplexer up here. If you didn't enable the RTC, you won't be able to change anything here. So now I changed to this multiplexer to use the low speed external clock. That means that crystal. If I'm not doing that, I will use the low-speed internal clock, and that one could be used for low-power applications. But in this case, I'm not using a low-power application, so I'm running with the external clock instead. So I get 32.768 kilohertz to the RTC. But as the main clock, it runs from the high-speed internal RC oscillator. So that one goes in here, and we just have in this application gone from this path, so we get 16 megahertz here. If you would like to have like 64 megahertz, which is the maximum frequency in for the G071, it says there below, you can just write 64. And the tool then selects the most suitable way to create this 64 bus clock. So you then get this, so it gets to internal clock here, it goes through the PLL, and it's go up here to 64 megahertz, and you get 64 megahertz clock. So you don't need to think too much about this. So we have an H clock, a high-speed bus clock on 64 megahertz, and we have a 32 kilohertz for the RTC. That is what you need to do here, and we are also going to think about, I said that we're going to set the timer and the clock with the UART, so we need to have a UART as well. So we take into connectivity, and we see that the UART 2 is already enabled, and that is why the reason for this is I said that enable all defaults to the standard. And since that UART is connected to the ST-Link, so I have the serial wire there on the UART. And what we can do here, we can see for the configuration on that one. So it's on synchronous mode, and it has the baud rate on 115.2 kilobit. So that is what we could do here. We could also take a look on the GPIO, because there is one PA5 green LED where we can use for instance, in my application, indicate when the alarm is set. So we see that the PA5, and we can also see that we have named it LED green. Great, so we build the project from here, and we can try to build it and to see just so there is no errors or no warnings. It's just a good thing to have. So this is now the main C file. And if you'd like to have this window a bit bigger, you can just double click on that one and it makes it bigger. And to reverse it, the same thing, double click it and it reverses back. But it gives you a bit more real estate when you are writing code and you don't want to see all the other stuff. Now to do this, we need to do some stuff, and I have prepared some code for it, and we will take a look at this. We're going to make some prints to the UART, and for that we need to have some includes. So we include the string.h and the stdio.h. That enables us for having communication on the UART. Then we can just go down to the private variables, and here we have the RTC handler, and it has a handler type called RTC. And also we have a UART called UART2. So those are the handlers for the RTC and the UART. I have created some piece of code that I have prepared because it will take too long time to write it here. But for the prototypes, we enter the prototypes here in the user code begin private function prototypes. So I have made now a prototype for setting the RTC time, setting the RTC date, setting the RTC alarm, and show a menu, and that is a menu that we will see on the UART. And then to print the current time, print the current date, and print the alarm set time. And then there is also two other functions here. That is the callback for the alarm when there is an alarm. If you remember, we choose not to get the alarm output to a pin. We wanted to have it at an interrupt instead. So that is the routine for that one. And we are going to have both communication, both from the UART and to the UART. So for that one, we also have an interrupt routine there. So we have made all the prototypes, and for the prototypes there must of course be code as well. So we take the code that I have written and just paste it under user code begin 0. So between the user code begin and end down here, so there is where you write your code. So if we then go to the first one, we have then a UART receive, where we have the prototype up here. So it receives some bits from the UART and puts it in the buffer. That is what it does. It's nothing else. And then we have set the RTC time, because in the CubeMX I said that we had a possibility to set the date when we create the code, but then that is static. So I choose not to do something like that. We can set it using the UART in my application. So we just transmit here to the UART, enter hours, enter minutes, enter seconds, etc., and waiting for the input here, UART receive, and that is the UART receive function you have up here. So we receive 2 characters from the UART, and we give that to the hours period, because we ask for the hours up here. So the first 2 digits we enter goes into the hour, and we set the time there. And then I ask for the minutes, and we get 2 new digits, and we put that in the minutes register for the RTC, and so on and so forth. And we also have the possibility to set daylight savings. I don't have daylight savings, yes, but you have the possibility to do so. And here you have the code for it. And also the store operation, so you have the code for that one as well. And then everything is done. We have then to set that time into the handler for the RTC. So in this case up here, we just populate this as time variable with all the datas. And when we have all the datas, we actually set the timer for it. And if it works fine, I then just transmit time if set. So if you get an error here and for one reason or another you can't set the time, it's out of scope or something like that, then you get that message there. The same is for the set RTC date, same as the RTC time, but in this case it's the S date that you use there. And the same again for RTC alarm. You do the same, and this is for the alarm A. Now, there is a rule that you shouldn't write redundant code, and this is exactly what I've done here. So there is a smarter way to do this, but this is a more understandable and easy way to see it. So you can, of course, do it much smarter than I have made in this a bit clumsy way. Then we also have a menu type, just not to enter the date and the time. We actually would like to see what the time is. And then we need to retrieve the RTC data from the RTC and print it to the UART. And this is what we do here in the print time. So we get the timer from the RTC and we populate the S timer here. We also print it to the printer then, of course. And the same thing with the date and the alarm. And then finally, I said that we had a menu, and that is for us to print out on the terminal to see what options we do have to enter on the terminal, what number to write to set the time and date, etc. So this is the menu, nothing fancy here. So this is just how to print something there. And there we also have something called a clear screen. We need to have that one there. So we need to also include the clear screen prototype. I will explain shortly what that is. Clear screen. No, I forgot. So what this does is when you have written some data, some text to the terminal, it's just scrolling, it adds text in the bottom. Eventually there is a lot of text and a lot of data on it, and the clear screen is to erase everything on the terminal and to put the cursor back to home position, up, left, and the right. So just make it nice and tidy. And it uses some code up here that we need also to do some defines. So we put them under type definitions there. So I put that on define escape and define the clear screen home and clear cursor home escape. So this escape sequence is what the teraterm, which emulates VT100, interprets and then erases everything on the screen and put it to the home cursor. So that is the clear screen, which is called in the menu up here. So whenever we show the menu, then we clear the screen. So when we then have written this, we transmit it to the UART. So that are all these initial. I will add some more routines later on where we would like to then add an OLED as well. So what we then do, we go here to the int main and we go all the way down to user code begin 2. We then write the first command, that is show the menu. So that will then go to the menu routine that we just shown and print out the menu to the terminal. We then go back down to here to the while one loop and it gives us some space. So what is happening now is that we show the menu and in the terminal, and the terminal is just sitting and waiting. So what we do here in the while one loop, we just get the set a variable called user choice, and we gave it the initial value 0, and then we wait for the user input, and that is the UART receive function that we looked in the very beginning there. So as soon as we have some 2 digits or 1 digit, because it says 1 digit there, because the menu is just 0 to 7. So it just waits for 1 digit. As soon as we hit 1 digit 0 to 7, it will populate the user choice with that number. And let's say, for instance, we hit the number 4. It uses this switch statement and it says if it's 0, no, if it's 1, if it's 2, if it's 3, it's 4, great. So then set the RTC time, because that is what we selected with the number 4. And then the set RTC time will execute. And then it will go further on here. And there we also have further on the alarm where we can reset it. And also if we write something that is not 0 to 7, that is an invalid input, so it says invalid choice, please try again. Now for the callback. So for the user code begin 4, there is where I normally put my callback functions. So for the alarm, there is a routine, so it's called HAL RTC alarm A event callback. And what I do in this case, as soon as there is an alarm, I will just set the pin for the LED, the green LED. We will put one more time callback here later, but for now we will just use this. And I think that we are complete, and hopefully there will be no errors when we build it. And thankfully it says 0 errors, 0 warnings. And now to program the device and see how it's working, then we need to have an UART. And I use the Terraterm. We build a project and we hit the debugger. So what we can do, we can clear the screen here and the buffer as well, so we have a blank sheet, so to say. And we can reset the microcontroller as well. If we now just hit run, now the code is running for us. We can see here that is the menu that I'm talked about. So what we now can do is, for instance, show time, and it writes the current time. And since we in CubeMX we initialized it to 0000, and it then is 13 seconds since we launched the microcontroller. But we can also take a look at the date, and that is also the same thing that we initialized in the CubeMX. And we can also see on the alarm what alarm we have set, and that is also 0. So that is not so fancy, but what we can do now is to set time. And for the microcontroller here, we don't see much happening here. But we can set time, for instance. So if we set the time with the number 4, we then ask for the hours. Yep. So time is set. So if we now show time again, it's now 12:30:05. And if we now set an alarm for 12:31, now we can get under 6, set alarm, 12:31:0. Alarm is set, so we can now show what we set alarm to. So that is 12:31. And if I now hit 0, I then refresh the menu, more or less. So we wait now for the green LED to lit up here when the time is 12:31. Yep, so we had an alarm at 12:31, so the LED was lit. And now we only have an LED. But imagine you could put a transistor to it and drive a heavy relay or something like that, so you could start or stop a motor or something like that. And we can then also reset the alarm by number 7. And then I hit 2 numbers, so I got invalid. So now we have this working here, and now we can take it to the next stage and also incorporate the OLED. And I made an OLED video, separate OLED video on it, and you can look on that one if you would like to have a separate, because I will go through this a bit quick. So I said that I made a separate video on the OLED, how we install that, and I made a separate video on that one. So take a look on how we do that, and I will just put, it's a link in the description as well if you have trouble finding it. So I will just jump to where I already have installed it. But what we can see here on the display that now have changed the G071 board, where there is an OLED board as well. So if you looked on the video or not, you can do it after this one, how to install the OLED. It's not very tricky. I did it for another display there. But the same thing that you just need to think about, this is the G071 I'm using in my application. You might be using another microcontroller, and then you need just to have the configuration file to point out what microcontroller you have. And we did that in the drivers OLED config file. So here in my application, I have now the G071. So if, for instance, you have the F103 blue pill or something like that, you will just have to go here and decomment this one and comment out the other one. So there is only one available for you. That is what you need to do there. In my demo for the OLED, there was no C0, and I showed also how to do that if there is no option for it. But we do have an option for G0, so just enable that one. So I was in the CubeMX, and we just hit the IOC file. If you don't know that, if you click for the IOC file, you will actually launch the CubeMX. So what we also did here, besides starting the I2C, where we have here, I also started a timer. And the reason for that is the timer 6. And the timer 6 I choose because that is a basic timer. It's not, there is fancy timers as well. Can do much things like Microcontroller stuff. But in this case, I just wanted to have a 1 second interrupt, nothing else. And for that, I will just use the basic timer. So if we recall, we had a clock on H clock on 64 megahertz, and I would like to have an interrupt on 1 second. So the configurations we do then is that when we enabled the timer 6, we then need to configure that one. And I configure then the prescaler to 64,000 minus 1, because you can also write 63,999, but I write this way because it's more convenient and it's more easy for me to understand. And also the counter period 1000 minus 1, and that gives you an interrupt that we have divided now the 64 megahertz down to 1 hertz, 1 clock cycle. And so you also need to enable the interrupt for this timer. So that is what I've done besides enable the OLED, which I also referred now to the older video. And let's go again then just build everything from there, and we can just build all the code. I will show what routines I also added here. So if we take the main C file, which we were just using, and I have added now some stuff here. So I included both these H files, those Studio IO and the string we had prior. So you need to add these two includes. This one we already had. And now you can see that we have enabled also, the CubeMX have enabled also this handler for the I2C and for the timer. So they are new versus before. And I also now have a couple more routines here. So I have a print date OLED and print time OLED. So we have the old print time and print date, but that goes to the time to the UART. But now I would like to have it also to the OLED. So we have here the clear screen. These are all the same. The print time, print date. But here we have the print OLED. And what I did, I just copied more or less the data from the print date to the print OLED and just made some small configuration changes to it. There is, however, some additional information here. I made a new buffer called buffer OLED instead of buffer. So now it's buffer OLED. And I gave it the size 15 and I initialized it with 0 to make it error. So that it's reset. That was the word. And then I make this printf to the buffer OLED instead to the buffer up here. That is what I did. What I then did that is more unique is these. So these are the SSD, that is for the OLED. So it's driven by the controller STM32. So then I just set the cursor to the X coordinate 15 and the Y coordinate 45. And the X coordinate 00 is up in the left corner on the display. And on the right, the X is 64 and 128, and the Y is 64. So then I write the string from the buffer OLED, which I have here, and I populate here with the font size and with the color white. And that is only writing to the memory location, and then I update the screen. Then we take the memory location and put that to the screen. And the same thing with the time. I didn't do anything for the alarm. That is something that you can do on your own if you like or require. So here under user code begin 2, we just had this line you show menu. These lines here are new, and I also forgot under user code begin 1, I made a menu or something like that, bragging PR Tech Talk RTC. So I just made a new string called OLED text. So here under user code begin 2, we have the init for the OLED to initialize, and we fill the background with the color black. It's a monochrome, so we have white and black to choose from. And then I write the string from the OLED text, that is this one, with the font size 11 times 18 with the character color white. And then afterwards I drew a line beneath that text and update the screen. And then I do the show menu for the terminal. Then we also need to do something else. We need to start the timer 6. We created the function in the CubeMX, but we need to start it. So that is what we do here. We start the timer. Nothing else here. We go down to the callback functions. So user code begin 4. So this one we already had prior, and this one is the new callback for the timer. So whenever the timer is running out on 1 second, it comes to here. And what does it do then? It do like this. It print the date OLED, and it prints the time OLED. And I also said in a previous episode that you don't want to do too much stuff in a callback function. So remember that this is just an easy way to do it. And the better way is to set just a flag in this callback and then just waiting and polling for that flag and act on that one. That is a better way to do it, because in this way you block everything during the time it takes to print the date and the time. So it works fine here, but it's not a recommended way to do it. Great. So what we now need to do is to try to build this one. We have the terminal up here again. And I will also take in the picture for the display there. And we can now then try to build a project. Like so. We can reset everything. We can manually clear the screen. Like so. And we see also the display on the OLED there. So if we run, we can now see that everything is running fine here. We can now see the OLED. We said it said PR Tech Talk with that font size. And there is a line underneath. And beneath there are, first of all, the time, where we can see the seconds increment once a second. And that the reason for this is the 1 second timer on timer 6. That is an interrupt once a second, and then it goes to pull the new time information and present it here. So that is why that is actively increasing all the time. and then we also have the date. But what we now can do on the terminal, we can then, for instance, set the date. So if we set the date, that is the number 5. So we then enter 24, 08, 10, and it then asks for which weekday as well. And Monday is 1, and today it's Saturday, so it's 6. So date is 6. And then that is automatically updated on the display as well, because it updates once a second. And we can also then set the time. We can on the terminal here, we can hit 0 to get the menu nice and fresh again. We can now then set the time, and we need to know 12:45. So now the time is 12:45. So I haven't incorporated an OLED to show when there is an alarm, and we have already shown when there is an alarm on the LED, and that's still working here. So I hope that this is giving you some toolbox that you can modify, make better, and work upon. I hope that you liked the video, and if you learned something, don't forget to subscribe and give it a thumbs up. And in the comments below, don't be shy. It's always nice to hear it was a great video, or this could be better, or you did that wrong, or such, because we all learn from it. If I make a mistake in this one, then we can make a learning from it as well. Hope to see you in the next video. So stay safe.